So moving on to question 2, we're dealing with inequalities here, and the fractional inequalities, and they're a little bit fiddly. Let's not lie. Some of the algebra can be a bit tricky to manipulate. Let's have a go at it, see if we can get there. So pause the video if you want to have a quick go, or you can follow along with me, but let's have a go for it. So first off, we need to simplify the left-hand side of this inequality, right? It's 1 minus x divided by x plus 2. So what I'm going to do is I'm going to times the 1 by x plus 2. So what that would be is x plus 2 minus x. I'm just going to quickly write it so you can see. So it would be x plus 2 minus x divided by x plus 2. But to save time, I'll just show you what's happening. That's just the x is going to cancel with the minus x. So what it's actually going to become is just 2 over x plus 2. So it'll look like this. It's going to be 2 over x plus 2. So that's if you want to show how to simplify the left-hand side. 2 over x plus 2. And this right-hand side will just be the same still. So that's going to be 4 over x plus 1. X plus 1. So that's that currently. And let's have a look at solving this now. So remember, when you're dealing with inequalities where you have x's, it doesn't have to be an x, but a variable on the bottom, when we multiply through now, we need to square the expression. So you need to remember that, and that's because we need to be careful about division by 0 and such. So this is going to give me now 2 times. So if you times, so what you're going to do is times both sides by x plus 2 squared and x plus 1 squared. But if I times this side, for example, by x plus 2 squared, one of the x plus 2's is going to cancel, right? The 1 on the numerator would cancel with the denominator, so I just get left with 1 in the numerator. So I'd get 2 lots of x plus 1 squared. Obviously there's no x plus 1's on this side, so it can't cancel. And I'll get 1 lot of x plus 2. The denominator term cancels. So I get x plus 2. Now this is going to be less than, so it's going to be 4 lots of x plus 2. So that's going to be this side now. You times it through by x plus 2. Obviously there's no x plus 2's on this side, so we can't cancel with anything. X plus 2 squared times by x plus 1. So now we need to have a go at simplifying this, and what I'm going to do is I'm going to take this side across here. I'm just going to keep it 0 on this side. Or you could do it the other way, but just make life easy. I'm going to take this across. So let's do that. X plus 1 squared, x plus 2. So clearly when I take this across now, the 4 is going to become negative. It's minus 4 lots of this. So minus 4 x plus 2 squared x plus 1. My mouse is being a bit fiddly today, so just ignore that. X plus 1. And this is less than 0 now, because we took it across. Notice here now, I can divide by a 2 here at this point. So what I'm going to get is x plus 1 squared. In fact, actually, tell you what, we'll make it even easier. What we can do is we can factor out from this point here now. We can factor from here. So what I'm going to do is I'm going to factor out a 2. Factor out a 2 from here. So that's going to give me, and what I can also take out with the 2, notice I've got an x plus 1 squared, x plus 2, x plus 2 squared, x plus 1. So what I'm going to take out is just an x plus 1 and an x plus 2. So it's going to be x plus 1 times x plus 2. And there we go. That's perfect. And now inside the bracket, what we're going to have, so we're going to have 2 lots. Well, we need to get something on this side. So we've got 2 times x plus 1 times x plus 2. We still need an x plus 1. So I'm going to have an x plus 1. X plus 1. Minus, so it's going to be minus 2 lots, because we need to make the minus 4. 2 times minus 2 minus 4. And I need on this side of the bracket an x plus 2, because notice this is x plus 2 squared. We only have 1 here. So that's x plus 2. X plus 2. And that's less than 0 still. Yep. From here now, what we need to do is just simplify this expression in the bracket. So it's going to be x plus 1, and then if you were to expand this out, this would be minus 2x minus 4. So what you'd get minus x minus 3 in that bit there, because it'd be x minus 2x, you get minus x, 1 minus 4, so minus 3. Then what I can do, because I've got a minus here, I can take out the minus as a factor, like a factor of minus 1. So I'm going to take that minus 1 to the front here with a 2 to make it minus 2. So that's going to become minus 2. So all we've done is took the factor bit here, or the cancelled bit here, and we've took a factor of minus 1 out. So that's going to be minus 2, lots of x plus 1, times x plus 2. And now, simplifying this is just going to be, you know, if you were to take the minus out, both terms will become positive, so that's going to be x plus 3. And that's what we get in the bracket, right? Because, you know, we've cancelled, or we're not cancelled, but we've took it out as a minus 1 here, but it's come to the front. So this just becomes x plus 3. And this is the inequality, so this is less than 0. So we're pretty much there now, guys. We've got the critical values, so they're going to be minus 1, minus 2, and minus 3. So now all we need to do is express it using set notation. So I'm going to write down the easiest way to figure this out using set notation would be to draw just a quick sketch of the graph. If you draw a quick sketch of the graph, it's really clear to see what it's going to be. So using set notation, I'll do it at the bottom here. So therefore, this is going to be, so ignore my squiggly brackets, and they're never very good. So that's going to be x is an element of the reals. And this is going to go from minus 3 to 2. Union. And then we're going to put the other side. This is going to be x, element of the reals. And this is going to be greater than minus 1. But like I said, guys, draw a sketch, and the set notation makes it a lot clearer. You get 4 marks for getting to this point. Sorry, 4 to get in for this point. You get an extra mark for your critical values, and the final mark comes from it being in set notation. So quite, you know, some tricky marks to be picked up there towards the end. But hopefully the first few parts are quite clear and simple. But there we go, that's the full solution. Job done.